Good afternoon. Welcome to Sister Sound. I'm your host, Josephine Johnson, and today we have joining us Dr. Karla Marriott. She is, let me check my notes here, an associate professor of chemistry and forensic science at Savannah State University. Your research includes grant projects for the National Institutes of Health, NASA, the Department of Defense, and the National Science Foundation. Most recently, she was awarded a patent for a molecule that she created, initially to combat the effects of addiction in the brain, but as it turns out, the molecule may have therapeutic benefits for neurodegenerative diseases like Alzheimer's and ALS. Dr. Marriott also heads up the forensic science program at Savannah State, but she's not always in the lab. She's also a painter whose work focuses on nature and the feminine. Her paintings were featured recently at a Savannah State exhibition. Hello, welcome. I'm honored that you are here today.
Thank you, Josephine.
Your CV is pretty impressive. You've been many places and you've studied lots of things. I first want to ask you about the molecule that you created. So I understand that you were hoping it would help chemically alleviate addiction in the brain, but it turns out that it does something else. Could you tell us a little bit about that?
Well, actually, initially when I wrote up the grant proposal to get funding to do the research, it was funded through the National Institute on Drug Abuse of the National Institute of Health, right, a part of the National Institute of Health. And I proposed synthesizing molecules to target the dopamine receptors, because I was focusing on addiction. But when it was funded, I did the research, and I not only screened to see if the molecules targeted dopamine receptors, but I also did a broad scale screen for all the other receptors in the central nervous system. And I found out that they didn't target the dopamine receptors, but they targeted another receptor called the sigma receptors.
Okay.
And so I was like, well, what are these sigma receptors? And I found out that sigma receptors have application in addiction, but it's even more broad in that it could also have application for treating other central nervous system associated disorders such as Alzheimer's, Parkinson's, etc. And it could still be used for addiction because there are central nervous system, factors within addiction. But this just broadens it and opens it up for even more than what I had initially planned it for. So that's kind of cool. I found sigma receptors to be even more interesting to me than what I initially expected.
Interesting. So the dopamine receptor, that's the thing that is in the brain that responds to the drug or the chemical.
Yes, and so you feel some reward from doing, for example, drugs of abuse such as cocaine, etc. Yeah, and doing anything that is pleasurable, like eating cheesecake from
chocolate.
Yes, there you go.
But the sigma receptors, can you explain again, how is that different from the dopamine receptor?
Well, they're kind of, they're little puppet masters, and they have a part in a lot of things, and, especially in controlling ion channels and helping the mitochondria to behave properly. So therefore, it implicates a lot of systems within the body, and so we are trying still to understand what it will do, what's the implication for it in terms of Alzheimer's. We know that there's some research linking it as a key player in that, but we're not exactly sure as to how it's doing what it's doing. It's implicated in restoring nerve damage, etc. So, and there's a potential that cholesterol is a part of that whole system where, plaque buildup might be associated with cholesterol or the diet, etc. And so we're not quite sure what is going on, but a lot more research needs to be done, clearly. But sigma is a complicated target, and that's why a lot of people have shied away a little bit at looking at sigma further. But hopefully this will renew a lot of interest. I know that some people are interested in looking at sigma receptors for the treatment of neurodegenerative disorders.
So you have a patent for this molecule?
Yes, we have a patent for a series of molecules that target the sigma receptors, because I didn't synthesize just one molecule, I synthesized a series of them. And we have ones that are strongly bind to the receptor, and ones that they're all pretty selective and bind well, but some more so than others. But the wonderful thing about this is that they're selective for sigma as opposed to any of the other central nervous system receptors. So therefore now we can target and look at sigma selectively and say that sigma, the activation of sigma-1 receptor is really leading to these changes.
Aha.
Yeah, so that's the key right there.
That's pioneering.
Yeah.
That's quite breakthrough.
That's cool, because
You're so modest about
if it targeted any other receptors as well, we'd say, well, we don't know which receptor is responsive.
Right, there are too many variables.
Right. So right here, at least we know that these molecules are selective for sigma, and anything that comes from that is related to that.
So what's the next step for these series of patented molecules?
To do more biological studies and toxicology studies. So I would like to look at biological partners, pharmaceutical partners, etc., so that they can assist in moving along these molecules, so that we can learn more about how it affects the biological pathway as it's related to central nervous system disorders.
So when you say partners, you're looking for other people who can help further this research, like
Yes.
to get it into test trials?
Yes, yes.
Okay.
Or to do further cell studies, etc. You know, it has to maybe animal studies, and because it's a transition from animal to humans, etc. So it's a long course, but we definitely have to keep the ball rolling because it's very promising.